Are you curious what I'm writing on this whiteboard? Well, as you see here, these are just a few of the things that I have learned over this past semester here at Carroll College, summarized in a nutshell. And I think this will be the topic of this video, is really how has my third semester gone, what should you expect the first time you're a sophomore in college, and why does this matter? So, as I start here, the first thing that I have written is force equals the change in momentum over change in time, and that's force equals dp over dt. And so, interestingly enough, if you've ever heard of force equals mass times acceleration, Sir Isaac Newton didn't actually come to that conclusion first. He came to this conclusion first, that the force and the vector sign I have above the F here, that the force equals the change in momentum, and momentum is defined as mass times velocity over the change in time. So if you were to distribute out the mass, you end up getting velocity, and so that's where, or acceleration, my bad. And so mass times acceleration is how you get derived from the change in momentum or change in time. And so why does that matter? Well, this little known fact really was the core of all these other physical topics that was discussed in my physics with calculus class. And this was by far the most challenging class I've experienced here yet. I will be lucky if I get a B after the final I took yesterday on Tuesday. And I don't know how I could have studied harder. The mathematical concepts, which I thought I was strong enough with during calculus, apparently didn't roll over into this class as well. The professor's ability to instruct might have been slightly off. The labs we did might have just not helped reinforce the ideas. But physics, in a nutshell, has been extremely fascinating to learn about, but also extremely defeating, because for me, who is someone who really likes to just get a topic and learn it fast and be able to move on from that topic and learn something new, I've really had to spend an extra amount of dedicated time focusing on these individual physics topics because it's just not clicking for me. And for any of you out there who are really high achievers, usually have things come to you real quick, things like this are just really humbling in their ability to really have you just focus back on what you know and what you need to know, knowing that you don't know it currently. And so physics has been that course for me this semester, definitely the biggest struggle. And I'm in OChem, and OChem has not come close to the challenges of physics with calculus. But talking about OChem, I have a Newman projection and this dibromo structure, which I thought just was something on the top of my head that summarized this semester of organic chemistry, beginning with how to 3D visualize models in a 2D plane, because reactions are done, of course, 3D, so being able to model that is huge as someone who's not well artistic. The second molecule is just knowing the different wedges and dashes of structures as you get into stereochemistry and different isomers and their orientations, like enantiomers and diastereomers, which, if you don't know, I have another video about a secret tool to ace organic chemistry that helped me hopefully get an A in the class. I'll tell you why I'm hopeful there for that. And the last thing I have is the ANOVA. And so if you've ever seen that word before, it's a variance term in statistics. And so ANOVA tests are helping you find out if one mean from multiple groups is statistically significantly different. And so when you have more than just two groups, but you have a multitude of groups, you use what's called an ANOVA test. And so we actually did our stats term project on the school's Wi-Fi, and we used an ANOVA test to complete that. So this term really stands out, something that I think will be useful in the sciences as you do like experimental control groups, multiple of them, you'd use an ANOVA test. And so these three things are my hardest classes here, were physics with calculus, organic chemistry, and statistics. But that really concludes with this at the bottom, 3/8. And that shows where I'm at. I'm officially, as of today, done with 3/8 of my college experience, which is kind of bewildering to think about, because just this last year it feels like I was a freshman, just starting college, just starting the experience, just starting sharing the journey with you guys. And to think that now I'm almost halfway there once I end next semester. And to really put that into perspective, college is such a whirlwind of a time, and while the struggles there, like this finals week I've just accomplished, you really need to take a time to focus and reflect on this time you have, because it's fleeting. And if you get so stuck in the weeds of what's going on or what you're looking forward to, then you won't enjoy it the same way. How has finals week looked like? Well, Monday I had my organic chemistry exam, and that was at 10 a.m. And so class structures are thrown out the finals week, and we have just dedicated times that are set out the semester ahead of when our finals will be. So mine, Monday, organic chemistry, Tuesday, physics with calculus, and that was at 8 a.m. And yeah, unfortunate time. And then Wednesday was stats at noon. And so today is still Wednesday, so I've officially completed all my finals. I had also one final last week for military history. That was on Thursday. I had a final paper for military history, and then I had a spectroscopy puzzle for our organic chemistry lab. So those were the classes I have been in, and just seeing, it's been such a growing semester. It's been fascinating with that, because to think at the beginning, when I took like a baseline organic chemistry test, and I'd be like, what's a diastereomer? Like, what? Like, force equals mass times acceleration. I know I've heard that, but what's torque? Like, what does it mean? It's the rotational equivalent of force? Oh, that's fascinating. So these just little things are like, what's an ANOVA test? I actually, funny story, used an ANOVA test through Excel's descriptive statistics last year for a biolab. Had no idea what it meant. Was hoping it went well, and I just used whatever the computer spat out. And now it's really cool to see, oh, that's what it means. Like, this is how we do it. It's really cool. And also with Army ROTC, new responsibilities, track, still practicing javelin throwing in the winter, knowing I won't compete till spring. Starting the podcast with my friend Riley, which I'll probably leave in a link in the description. It's called Crux of the Matter. And just the time of such, growth and reflection, and getting to face challenges like physics here and really say, I can't beat it by myself. I really have to go ask people for help. I have to get a tutor, and things like that, where you just have to be humbled by it. And knowing that the journey for medical school is ahead, but not to know that that's not your end goal. College is currently the place to be, and that's where we should really invest our time. And how did I study? I mean, last thing is, you don't want to cram everything immediately. You do need to prioritize how your finals are going. So on Monday with my OChem test, I prioritized OChem for the weekend. Physics, well, after OChem was done, I went straight to physics, and stats, I went straight to stats after my physics final. So the studying process was setting priorities, it was getting good sleep, it was eating right. I know there's a lot of students around me who are staying up till 1:30, 2:30 in the morning trying to cram stuff, or else waking up at 4:30 in the morning to complete an assignment before the final. It's just not a smart idea. Because the Army Triad, of course, preaches exercise, nutrition, sleep. The three things that are most baseline that you are in control of, that you need to get to really succeed on your finals. And besides that, I think just mind mapping, organize your thoughts out in a list, connect things that work together. Physics was especially huge, because it seemed like we just had all these equations floating around our head. But if we could break them down into kinematics, to dynamics, to torque problems, to how torque relates to energy problems, organic chemistry, if we could really break down. I took away one huge lesson from organic chemistry, and it is this: molecular reactions are lazy. That's it, like, what, 4 words? Just really hilariously simple in their process of, they want to get the least amount of activation energy to complete the reaction to its fullest. So what are they going to do? They're going to try to orient themselves in the least strained way, where they're going to react the least amount of energy possible, and that's all organic chemistry. And you just have to learn what is the result of that lazy reaction. And stats, I mean, it's just something that when we're thrown in the world of data, to really know, looking at this chart, does this actually mean what I think it means, or are they trying to mislead me? These are all practical things that I think really highlights the learning process, that rather than treating it as just a grade to put on a transcript, really ask yourself, how can this apply to my life? Why am I taking this class? And how can I, of course, I wrote this in my book too, don't let the system school you, but let you school the system. Not much else to say. Use the system to your advantage and don't let the system use you. So, as always, ad meliora. Merry Christmas, everyone, and I'll see you guys later.